So today, the last panel today is looking specifically at open source at UCSC. And the open source ecosystems and innovation at UC Santa Cruz. I'm really happy to bring to the stage the 5 of really people working on some really innovative and great things for open source. One of them is just helping innovation throughout campus. And we're excited to start working with them there at the far end. But the purpose of this panel is really to highlight the open source work that we're doing here at UCSC, and the extent to which that work in open source is enabling a greater impact for the research being done here, as well as all of our education needs and mandates that we have as a university. Now, as part of the office that I'm part of, the OSPO, we specifically want to champion open source. So I'm also really interested in hearing, especially from our researchers on the panel, how the campus could support innovation and entrepreneurship. I'm sure Ben would like to hear that too. And how foster and support the work that you're doing, as well as other similar type of work at UCSC. Like I said, we're really lucky to have the experts out here on the stage, people working in software, hardware, scientific software, and education, as well as Ben, we're really looking at a lot of efforts to promote innovation on campus. Now, the first part of the panel will specifically allow each of the panelists to talk. I think we said about 6 minutes each, or take about introducing the work they're doing in open source, what specific value they see in taking this open source approach, and that's specifically for the researchers on the stage. Or efforts to support innovative work, like what Ben's working on, including open source research on campus. I'd like to see how everyone is currently, also if you want to address this, if you feel comfortable, talk about how you're currently funded, talk about how support happens and what the needs are there. And especially if you're being federal funded, like the POSE grant that I know that Eric's project is on, and other NSF projects or industry partnerships or other sponsors, just to give people an idea of where that value is coming from or being seen on the funding side. Now, of course, if you guys want to, any of y'all want to expand beyond that, feel free. We're really open. And then after that, we'll do a couple of questions for the panel, and then I'll open up for hopefully to about 10 minutes of Q&A. So I'm going to go, I'll just go this way, if that works. Emily, if you might start. And I'll ask each person to introduce themselves as well.
Sure. Hi, everyone. My name is Emily Lovell. I'm a postdoc here at UCSC and funded by our open source program office. I'm going to talk a little bit about some of the work I do with students. In particular, I'm going to focus on a new program called the Contributor Panelist program. So this is a summer program. I'll go into more detail, but it's a summer program that supports specifically students from historically Black colleges and universities in learning about open source culture, learning about open source tools, all the way through making their first contribution and then trying to really contribute to an open source project that's outside of the university. This program initially was funded by internally through funding from it's formerly known as the Inclusive Excellence Hub through Baskin Engineering. I think Marcelo is here who leads that. But yeah, we're really grateful for that funding, and we now have funding from the National Science Foundation to continue. So I guess there's a couple questions first. Why open source leadership? And maybe also why HBCU students. So open source, we're all here because we care and we probably are already sold. But in terms of working with students and teaching and mentorship, I think this is such a cool space to work because students get to build a portfolio that other people can see that's not bound by non-disclosure agreements and that kind of thing. They get real experience with tools and communication and collaboration. they can impact something they care about, whether that's just keep going. They can impact something they care about, whether that's like a project that they think is really cool, or a tool that they use, or a, something that's socially important to them. Mentorship in particular, I think is really different than just say teaching in this space, because you can shepherd students into a community with support to have, the confidence, or to create this sort of like brave space, as Scott said, to support students contributing. And something that really drew me to it was helping students feel like they belong in tech, who maybe have historically been marginalized in this space. And in terms of HBCU students, we started working, with an HBCU really because we had an existing relationship with the faculty member at Norfolk State University through Carlos Molzon, who is now retired but was the prior director of our OSPO, and really just got to know her and hear about her students, and that these were opportunities they weren't getting in the classroom that we could help support. So it's an 8-week summer program. Students spend 4 weeks here on campus in Santa Cruz, where we do like a workshop style instruction with me, their cohort, also with alumni mentors who participated in the program before. And we also do a lot of community building, like social events. We go visit a tech company every year. We went to GitHub this year. It was super cool. And students get to learn about both graduate school pathways and industry pathways in open source. And then during the remote part of the program, we really focus on like, how do you use remote collaboration tools? How do you work with a distributed team? And let's go contribute to a project together. These are the just extra details. We pay the students basically, which I think is really important. So we pay the students to participate. We fund all their travel, housing, and we also work with faculty partners at HBCUs to help understand, like, what might help their students like be more successful in the program, be more interested in the program, basically have a positive experience, including like prerequisites at their school. So I'm not going to like explain this example because it's just a GitHub conversation, but this it's a video that I don't think is going to play. But my students had worked in 2 projects. Last year they contributed to P5JS. This year they worked actually in OpenSSF, so they contributed to scorecards. So thanks for the intro in the prior session. I let the students pick. I guide them based on things that I would look for in a welcoming community. But then they do the assessment, like they whiteboard, they compare, they go sit and lurk in Slack channels, etc. And they decide, and I support them. So this is just a very cool example, because this is a case where a student last year actually went and found like an issue that was like, I don't know, 6 years old or something really, really stale, and advocated within the community with the support of the other students to get something changed, and got this code contribution merged. And it affects all Windows users. So like, how cool is that? Okay, I only have 1 minute left, which is cool. I mostly have pictures. This is last year's cohort. We went to San Francisco. We visited Sean Smith, who actually is a PhD alum from Santa Cruz. He's on the gaming t-shirt. And so that was our first tech company visit. This year, we had a bunch of adventures. We went down to Big Sur. We always had like a welcome dinner. And then you can see like, this is kind of how we work. Like we work in our lab for half the program together. And then we also work on Zoom for the other half of the program. So what's next? We have funding from NSF to grow the program over the next 3 years. If you'd like to be like involved or interact with the students or support, I'd love to talk. We're going to be growing our partnership to 6 different HBCUs with cohorts of up to 24 students. We started with 4, so that's neat. We're going to just increase a lot of our collaboration, have more input from HBCU faculty members, and hopefully start to offer some workshops to support HBCU faculty, like infusing open source into their curriculum, whether that's like one assignment or a whole class. So I'm still looking for funding for that, but that's one of the big projects ahead, hopefully. So yeah, I think that's it. Contact me if you want to talk.
So let me do a little bit introduction of the projects that why I started open source, and then how I'm supporting open source in the university, why it's specifically. So I was looking for the time, so I started with before internet, it was a BBS, it was an encryption library, and we posted. I don't even know what's license because before it was popular. For Common Amiga, and later I started to work on Linux kernel packages inside. So that got me very interested. As a result, when I started as a university faculty, that's many years later, like 10 years later, I was clear for me that I was going to be having open source projects and support them. So what I started is like I'm going to tell you several projects I've been supporting them through the years. So the first one that I started, it was like the what? My name is Renau. I'm a professor of computer science and engineering. I've been since 2004. So the first project I started as open source since 2004. The other project I was coming just from the early 90s. And I was an undergrad student, and the Linux kernel patches were when I was a master's. So why do I start calling support the university projects open source like that? So I started project should be supported the longest is the performance modeling that we have. So I'm a computer architect, so we need to have performance models for CPUs. It's something that I developed for my PhD and we open source inside the research group. It was the first time that we did that when I was in the PhD in Renau. And then since then I've been maintaining. So how can I maintain that software? One thing, I'm still the lead contributor, which is not great, but that one. Then the other one is like many times there is some for a performance model PhD students need it because they might propose some new architectural change. So then they're going to be changing the thing. And they use it as infrastructure and they have some NSF run that is important, but it's not really it's a byproduct. It's not the target. Then the other one that is happened quite frequently is that maybe sometimes they were targeting the model by itself because they were trying to improve the sampling techniques, new techniques for sampling to performance modeling to work in multi-cores and things like that. So that was a specific NSF for that. Then later I have another NSF that it was more infrastructure. That was just to support the infrastructure directly so that other people use it. And that has been the main. So clearly the contributions through 20-something years, there's been side products. That's why it was maintained. It has evolved quite a bit through the time. One interesting thing that it had some support is that some of the students, when they graduated, they use it for consulting, and then they contribute back. For example, Intel is using it in some of the products. I think that used to use it. No, it's no longer interact with them. So there are several companies who have been using it and they have been contributing back. So that's one. Then, and that one I would say is the longest, more successful. Then I have some other ones in which we try to extract. Usually we always extract with some NSF, or in this case it was an Army grant, DoD for a new infrastructure. It was for chip design infrastructure. This one was maybe too big. And I have help from industry to contribute, but the mostly in support for the PhD students, not their contributions. And the thing is still an ongoing event, so it's like many years on the making. Those are the two sort of biggest projects that they multi-PhD students. Now, one thing that is, as a university, being able to do a lot of little open source projects or contributing to this one is through master students. So it's similar to what I was mentioning before. When I started, one of my contributions was to the Linux kernel, and that started as a master thesis for me when I was a student in Spain, in undergrad. So I proposed many master student projects that they work. Hopefully, they do a PR and contribution. Many times they do, sometimes they don't. But it works towards that area. And it's usually, the problem is that it's 1 quarter and a half, 2 quarters. So it's difficult to learn, to push it and do a contribution. But through that, I tried several times because the PhD student time is supposed to do more research. It's a little off-site on the infrastructure, but it should not be the main focus.
Share some slides. Hey everybody, I'm Eric. I'm a PhD candidate here at UCSC. I'm working with my advisor, Daniel Fremont, who was here earlier, but he had to leave unfortunately just for this session to go to this class. So I will be presenting, and I'm going to present on our project here, which is Scenic, a probabilistic programming language for modeling the environments of cyber-physical systems. So I want to start by just getting into what Scenic is, and there's big jargon here, which I'm going to unpack. So Scenic is a domain-specific language for cyber-physical systems environment modeling, and it does that by defining a distribution over environments of the system with probabilistic agent policies. And all that means is a cyber-physical system is a system that interacts with its environment, like a self-driving car, a drone, a UAV, a robot, and a farm. Those are all cyber-physical systems, and its environment is where it is and things around it. So for a self-driving car, that might be the road network, pedestrians, other cars. And you're defining the environment by placing constraints on where things are, what they're doing, and you can sort of use that to test or several other use cases. And it's designed to be precise yet readable with a natural language syntax. So here's an example of a simple Scenic program on the bottom right, which basically just might be a little small, but it basically just picks a point on the curve, you pick an angle that's random, you put a parked car there, then you place another car that can see that car. If you want to test your system to see if it can identify this is a badly parked car on the side of it. So this is a really simple example, but at its core, Scenic program is a formal model of a system's environment. And you can use it for a lot of things, like testing a system, generating synthetic training data, finding bugs in your system that might be really difficult to analyze otherwise. So that's a lot of technical specification, but to sort of motivate it, here's a bunch of use cases that we've applied Scenic to. So on the top left is the Toyota human support robot. This is a situation where we're trying to train it to pick up a bottle off a table while navigating around chairs. On the right there is an autonomous driving scenario where a car is being tested against another car, pulls in front of it, and has to stop so it doesn't get into a collision. On the bottom left is a taxinet system. So this is provided by Boeing to test a system for taxiing. And here's a bug where it veers off the runway, which is not what you want. And on the bottom right is a reinforcement learning application where we're training an agent to play stalker. So that's what Scenic is, but I'm mostly here to talk about Scenic and open source, why we picked an open source project for Scenic, and what we're doing right now. So from our perspective, being open source has a lot of benefits. First of all, it's easier to utilize. So there's no cost to users or limitations on the software. So people are more eager to try it. We've had a lot of people in academia, students who use it for projects, people in industry who can just use it without any authorization and funding. And we also have the source code there. So if you have an issue on top of the documentation that we try to develop, you can also just look at the code and see what it is that's going wrong or what you want it to do. It's also easier for users to extend for their purposes. They can force the repository or make pull requests. We've talked to a lot of users who specifically said that they picked Scenic because none of the software out there that doesn't see that's sort of in this niche could do what they wanted, including Scenic, but they could modify Scenic with very little extra effort to do what they wanted. It's also users can contribute and guide the development. It attracts students and others, like in class projects, you want to give back to the community or are interested in working on it, and you might want to just extend the language in some way. And we think that a democratic approach to development really gives us a competitive edge because we feel that we can better fit our users' needs when they can tell us what they want. We can add it, and we're not worried really as much about the customer, the selling. We just really listen to what they want and say, this is useful, it would help our research, I'll make a fee off for it. Our long-term goals for Scenic are really, we want a self-sustaining ecosystem because it's primarily being developed by the research groups who founded Scenic at Berkeley here. And also we want to develop Scenic into a standard. So it's an open source project. It's a formal description of its environment. We want buy-in from regulators, academia, and industry. We would love it if to certify your self-driving car for the road, it has to pass 100 Scenic scenarios. That's not crash all these situations. So right now, what we're doing going forwards as an open source project is we're really lucky in that we have funding from this NSF Post grant. For those who don't know what that is, it's just a grant that really gives us money, not just for research, but to develop Scenic and the open source ecosystem around Scenic. So it includes funding for developing the language as a research project, but also for a research engineer who can work on CI/CD, who can work on making the documentation, and we also get funding for workshops and outreach in general. So using that, we're working on establishing a steering committee and working groups to guide the direction of Scenic overall as a language and with different domains like drones, UAVs, self-driving robotics. We're also working on Scenic education in the form of a forum, and we've had several working on several Scenic workshops. We've had one already. And also infrastructure to ease the development of Scenic and make it easier for us to accept pull requests or contributions from users. We're also doing outreach to various stakeholders and potential users because we've had many industry collaborations in the past, but we really want to work beyond just collaborations and sort of get Scenic integrated in companies' workflows because we think it's a useful tool and we want to help make sure that we're stable and usable and we don't break things for them so they can rely on us as a tool. Yeah, and finally, the thing that's really confusing us is sort of the fiscal side of the project. We're looking for maybe a fiscal sponsor because we want to explore industry sponsorships and other funding sources once we pass this post grant. We want to see about sort of sustaining funding in that way so we can continue these things without NSF funding. Yeah. So I'll pass it to the next speaker. Thank you.
Thanks. Okay. I'm trying to talk about why. I'm Giordon Stark. I am an assistant project scientist at UCSC. I had a postdoc in education in 2018, or you can only do a postdoc for so. So there's a lot I can talk about. I am a particle physicist with SCIPP, which is a standard inclusive computer particle physics. And I'm here today to talk both about some of the work that I do, but also high energy physics as a whole, physics. But before I do that, how many people have heard about Southern sea level and Southern? Oh, okay. I don't have to talk too much about this. Okay. So I've been with Southern since 2014, and so I'm working on one of the larger experiments, the Atlas experiment. It's a large collaboration of about 6,000 people or so. So there's quite a lot of people. CMS has about 5,000, and then there are also other particle physics experiments that are not as known, such as poetry, or MIRIC, or the EIC, or the Long Collider, or Copper Collider, and so on. All of these are kind of under the umbrella of high energy physics, or you might have heard about Green, for example, Lab, and North Dakota. All of these are physics, and along with the work that I do is both on the data analysis side as well as hardware and software. So I'll try to break it down just a little bit on how this relates to works. One of the great things for us, or at least my personal advice, is that in order to enable students to do their work efficiently and to be able to train students not only to stay in academia, but to allow them to transition out of academia, you don't want to develop some sort of in-house piece of code because they get trained very specifically on that, and it's not a transferable skill to them. That makes it much harder because then they're kind of stuck. They leave academia, but then maybe they realize they're not actually really know how to program. They just use how to play around and get intuition with this very esoteric tool that nobody else uses. So with that in mind, there's a couple of different things that I have worked on. On the hardware side of things, I've worked on electronic delivery systems as well as electronic systems. That is currently what we work on here at Scenic. Some of the open source projects you see in there include, for example, remote control and monitoring of lab, such as power supply, multimeters, and oscilloscope. And there's a project there called Renau that is in partnership with the lab and a couple of other laboratory institutions, where it's a modular C++ framework that allows you to kind of plug and play new additional equipment. So if you purchase like different power supplies and make it running libraries, such as easily versus voltage wars, you're able to plug in a new C++ file into this, Python bindings and interact with this actually one with other power supply in the lab, where you are consistent interface because every single manufacturer has their own perspective on how you should communicate and qualify. But that's kind of the point where when all you can take off, if you have to control it, or remote beyond it. Not that as an example, right? Look to have other software there for being able to read out names to context switches, which we are using for the upgrade of the active detector in 2029. And that software is a data acquisition system, mostly written in C++. I believe there's a little bit of Fortran in there, but that's on the hardware side. I want to talk a little bit about the software side, which encompasses a lot. So when I mean software, I mean from pure software perspective within the foundation. I've been doing quite some levels getting involved software. Software that I'm talking about my mind is getting into, for example, a statistical framework that we wrote in 2018, 2019 or so. And the goal of that was to allow for improved communication between experimentalists and peers when we're talking about results that we publish in Incubator. One of the hardest parts is that we publish results as paper form. It's great because on some level we're trying to make the physics or the science of doing reproducible, but then it's kind of hard to be reproducible if you're forcing people to read off the plot numbers from a PDF form of a histogram or some sort of plot that you make, they don't know the actual number. You want to be able to serialize that plot and like each readable format so that they don't have so they doesn't have to make their own digitized version of your table to figure out the version. And this is tricky to talk about probability model, but you need a way to serialize it again. And sort of a package called Hydrochart, PYHN. We wrote in 2018, 2019. And it's been about 5 years now or so, and we have a little over 130 citations. And it's being used by more than just hackers. It's being used by pretty much all our computers as well as in particular. And all of this is because we are trying to contribute back to open source, relying on all of these tools to make sure that any of this training we're doing is not shared within the collaboration. It enables all the students that would be able to go out and do work beyond that. At the end of the day, it's all about knowledge transfer. I'm not going to be around forever. I do not want to be the expert, but I want to be able to make sure somebody else can take over from what I do. But to make that happen, it needs to be put out in the world for other people to take care of and shit.
Oh, yeah, go for it. Say, do you want to move on? So you can say that. No, I think you're fine. Whatever. No, I'm just trying. Whoever is not done, I'm trying to. It was like hitting the right on Jose, so I was like, oh my god. No, sorry, Ben, you're up.
Hello, my name is Benjamin Lovell. I'm Director for New Venture Development. So everything I'm going to talk about here is not software related. How's that? So when it comes to ecosystems at UC Santa Cruz, my role here is to help people translate their technologies and inventions out into the world. So I work with all the units on campus, but I can see 3 of them right here already. So, but what it comes down to is innovation and entrepreneurship. So, for example, some of the commercialization or some of the efforts that we're trying to put in place, we're doing an ideathon for undergraduate students coming up on October 18th, where there's an open source track to it. So students can take these problem sets that we're posing to them, and they can come up with creative and exciting solutions. Thinking outside the box, can they incorporate a way of saying, hey, can we do this using open source as well? And then we'll be able to reward them and then invite them to be able to execute on those dreams or those ideas over the course of the school. So what else we do out of the Innovation Business Engagement Hub is that we talk about intellectual property, we talk about incorporation, and all these very boring, exciting, the exciting world of business models and things like that too. But the question is, how can you take your technology that excites you, is something you're passionate about? How can I work with you to help you with your team, get your team together, have all of you come together, find a way of actually getting your technology out in the world so people can see what you've done. For faculty members, we're doing a innovation catalyst grant. We actually just released that for faculty members that are generating intellectual property here at the university. So, and the whole point of these proof of concept grants are actually not only to give you funding to be able to get to translate and de-risk your technology, but also for us to provide practical commercialization experience and training and workshops so that you can actually get it out the door. So it's not just sitting here inside of the UC Santa Cruz. So back to one of the questions from the last panel with industry experts, where they're saying, what are we doing? And who's that point of contact to be able to see what kind of exciting things are happening on campus? I've been here since last December. I have a database of about 80 different technologies as of right now that are exciting. And I know this database is nowhere even close to being filled out of everything from ag tech all the way through cybersecurity to pretty much name. Actually, we even do have a group that is trying to take wastewater and develop and extrapolate energy. So we even have that project that we funded to be able to de-risk it. So this is the kind of ecosystem that we're trying to establish here, is to say, how can we make things inclusive through and through? And this is for grad students, it's for faculty, as well as undergraduates. So that's pretty. Am I missing anything here, Stephanie?
No, I think-
All right, that's my plug, and there was not one I can.
Well done.
All right.
All right, great. Well, thank you for the panel for their introductions to what they're doing. I'm going to just ask a couple of questions and then probably open it up to the audience, because I think they covered a lot of the stuff that I kind of had questions about. But I'm also opening it up to our panel because it's a very diverse group that would be happy to ask across to each other about, especially if people have specific questions for the way that Ben's work works, or if Ben had any questions, like the different questions that might come up from having this group together on the same stage. But my first question, kind of just for the group, would be kind of what areas, kind of related to what I was just saying, what areas of support do you need? Now, like the OSPO is trying in particular to figure out how to leverage open source to help your research or help our education mandate within UCSC. And we're still trying to figure out, and all of the academic hospitals are still trying to kind of figure that out best to do that. So it's really good to hear back from the researchers and the other folks working in this field about what supports do you actually need from on campus or outside of campus to actually do what you're trying to do to have the largest impact, either from your project or a program like Emily's program or something along those lines. So I'll start to let's start. Okay. Let's say
Wish list. One is like thanks for the support to work with, because some things that are very useful is like helping to coordinate a Google summer code. That's very useful. The other one is any GSR for supporting the students. I think very useful too. I understand that it's binary to provide GSR or not, so maybe contribute to like 10% or something like that. It might be an easier, lower threshold. That is also very useful. Now, one thing that is on my wish list, and I've been trying it sometimes with NSF, but not so successful, is to have a professional programmer that is time share across projects, because there are a lot of things when you are doing open source, like maybe the website, maybe the CI, maybe there is the license, maybe there is blah, blah, blah. There is a lot of little things, and having a PhD student or student who is expert on everything is too much. And it's too many things that are easy for a professional programmer to time share across projects in the university. So that will be very useful too. Those are the easy things for me.
What did GSR?
The GSR is, for people who are not aware, is support for the student, so they don't have to do a TA or pay themselves, which is very rare for PhD. But you can do that for, it's a financial support for the student, so you pay the tuition and some small salary. Who do I message? What's the wish list? There.
So I agree with that. So with the post grant, we have the ability to hire a sort of staff engineer, which is super helpful because there's a lot of issues that get posted or on GitHub, a lot of PRs and stuff, and just even not fixing those, but triaging them, making sure that they're actual bugs. That takes a lot of time. And as the person You had to do most of the grunt work on the Scenic repo before we got the engineer. I'm very glad to not be doing that anymore. Because all those hours are hours I can't spend on my research. So that's great, and I really like that. The NSF post funding is paying for that. Once that funding runs out, we need to find another way to get money. And we have a lot of industry collaborators are using our software. So there's been a lot of discussion in our group about how we can maybe, get financial support from them because they're using it. We don't know if it's maybe we can help them integrate Scenic with their software, some sort of licensing deal, even though it's open source, or maybe just donations. But that's something that we also are not familiar with, and we don't really want to have to deal with because that's not what we're doing as researchers. So it would be great if we could have somebody who could sort of take care of that for the financial side and then handle the
For your engineers that are funded by local government project, many of those engineers be basically hire understaffed rather than under the university. This is much more complicated and I'm not the best person to share on that. But those engineers get the contract across all different projects, across all different professors and different grant. Because you say this person gets 10% from the professor's grant and the professor's grant. And for the most part, we just kind of collaborate to share that engineer. It would be nice to see that on some level, like a research software engineer coming in, or located in the first 50 cars. No, you offer money to students sometimes just need software help rather than say science help or physics help. And there's only so much time in the day to be able to sit down and train someone on the standard of anything that is not very contact with the subject kind of law, for example. One thing that I want to add on for in terms of funding, a lot of the funding that I see nowadays is R&D specific. And that's slightly worries me because there are going to be projects that are not necessarily R&D anymore. They exist, they have a large user base, but there's not much more you can expand on that project. And now you don't have funding to just kind of have to leave it or hope somebody else will get out the do it out of kindness of their own right. I don't think NSF will really have a way of supporting software funding from a main perspective, only from an R&D.
I want to hear your problems. That's what it comes down to. I'm not gonna have solutions for all of them, but for example, what you just said, saying we need money. The answer is I may not be able to give you money, but I might be able to give you solutions. So you're saying, okay, you're looking for answers on how to possibly monetize your open source software with your industry partners. That's where you would come to us and be able to have a conversation with us so that we can see how we might be able to work it within the confines of the UC system to be able to make that happen. And when it comes down to contracts, that's what happens out of the innovation transfer unit of the IBE Hub. I use an acronym, I'm sorry. But that's what happens out of the hub is that we actually try and find ways of making that happen. So our goal is to be able to make these types of conversations much more open and transparent and be able to find ways of connecting the dots between industry, between different units on campus, and be able to back to it, translate your technology out into the world so you can feel like it's being used. And so that you can say that all this hard work I've been doing here at the university is actually making an impact. So, and as much as it's great to be able to protest and make statements, and it still works to some extent, our system has slowly but surely changed so that corporate entities have more of a voice and being able to translate their product into the world makes more of an impact. And it's sad to say, and it hurts for me to say that, but this is where I'm seeing the academic trend going, is being able to say, hey, look, let's not only develop something in the university, and let's figure out how we can translate it so that we can make it a bigger, larger impact, whether it's on societal end or for profit end. So, that all being said, some of the training workshops I'm putting together on how to start up a 501c3 or benefit corporation, as well as an LLC or a C corporation, so that we're not just sitting here just pushing for profit, for profit. We're pushing, how do you get your technology or your message out?
Eric, do you want to get out the time?
So I work for the OSPO, so I'm about to maybe give myself more work, but I'm not gonna
To say no.
yeah. Or with telling Steph to say no to things, because she's a yes woman. Should have told you guys that. I hear the need. We hear this from a lot of people. We do a lot of meetings with people on campus that we're like to talk about really exciting projects. And how can we get them funded? What are the needs? And one of the needs that we hear a lot, which I also heard today, is like, it would be so great to have a software engineer who could help with these things and maintaining these projects. And I totally agree with that. But my counterpoint is that we also run a campus with like so many skilled, qualified, motivated students that I think I think this is like an untapped resource that we just haven't made some of these connections yet. And that's the part where I'm like maybe giving myself more work. But for example, in the mentorship program that I run, this last year was the first year, so we didn't have an alumni mentor. It was just me working with the students. This year, I had one alumni mentor, and like my stress level was way down. Like that student was like helping run things. Like I could leave the room and take care of stuff this year. You know, it makes such a big difference to have students and to like, and it's such a cool way for us to also empower them, right? To like take leadership and do these things. So I totally agree with the sentiment that students also have a lot of other things competing for their attention, and it's not the same as having like a full-time dedicated software engineer. But I hope that in the next few years, I can convince more people on campus to invest in like the training and mentorship, you know, that you can even assign your grad students to do maybe to help like grow those communities, because I think that we could go really, really far together.
I also want to kind of second a little bit what Emily was saying, where I'm also one who actually, when we've done post projects, we've like tried to put that exact person in there. Like we want to have the, you know, a percentage of a developer, or a percentage of a software engineer. But I thought one of the ideas we've also had, and you could comment about this or not, is to have a team, so like that person, have an individual, but have that person actually managing a team of students as well, and maybe having like a you know, OS, like an open source undergraduate team that goes out. And there are actually, St. Louis University has done something similar. Their OSPO has done something similar. That's actually been pretty successful. University of Vermont has too. So we are looking into that as an option as well. Aside from just putting it in the book, like our grants. Oh, sure.
I was just also going to add that I think by involving more students in projects, we also hope to grow like resilient communities instead of just having like one project with like a staff maintainer and that kind of thing. So yeah, totally agree. Yeah, it would be amazing to have professional software engineers working with us. We hope to get there, but I also think this is like a great way to convert communities, which is important.
Great. I have one more question, and then I'll open it up to the audience for Q&A. One question I have, you all have kind of varying levels and varying types of levels of working in open source and innovation activities. What would you, what kind of advice would you give to folks from the academic, you know, new researchers coming into open source about starting an academic open source project? And in particular, what pitfalls would you try to like avoid, or challenges do you think that people could, you know, figure out ways of getting around?
I can go first because I'll be fast. One of the like main things that I recommend to academics that I meet who don't have open source experience is just like go to an open source conference. Like I think that the cultural piece of open source is so cool and also important if you want to have a thriving open source community. So yeah, like there's so many of them. Like find one, go. Carlos and Steph sent me to one right after I started my postdoc. It was phenomenal.
People like Spot, Vicky, and Karsten.
Yeah, you'll find out the community, and also just realize that you don't have to do everything alone. It's much harder that way.
trying to find a balance between the contribution to open source and the publication. Because depending what target you're gonna be doing, you want to go to academic, it's more important one or the other. And it's a balance, so you go to the industry, you can go more on the open source side or not. But really, you have to think about it, how much time can I put to this? How much time can I put to that? Because you have to balance.
One thing that I didn't appreciate going in that my advisor was really strict about, not, she's really serious about, is respecting your users, because I think it's really hard to build up a user base and get people who trust your software, who use your software, and you can really easily undo it. And by that I mean, like, keep your document, like, put effort into your documentation. Do not break backwards compatibility, because once you have people relying on your software, it's really, they will leave if you just make it a pain to use it, even if they've been using it, or they'll just stop updating it and they'll fork it. Yeah, so I think that's one thing that you have to be really careful about. And I think there's a tendency in academic projects to sort of just, you know, okay, I'm gonna break everything because I have this new great idea, and suddenly all these other people who are depending on your project can't use it anymore. I think that's really dangerous to do, because you will very quickly lose users.
I think that's the first thing I started about the get the project community. Pretty much everybody hopefully sort of like 9 years, like that's 2 or 3 of mine. I've been already with somebody else. Whether it's with somebody else in the same project, or somebody else in the same collaboration, or just a random friend that I met playing StarCraft back in 2008. There are some sort of community there. It's much easier to do any sort of open source project if you're not alone. But if you are, you can make friends with GitHub Actions or GitLab CI/CD, and let them do a lot of the work for you and try to automate as much of the process as you can. It's probably easier to do any sort of development work if you have decent documentation, if you have the infrastructure in place. They can always adding more and more things implemented. But if it's always a pain or it's blocked, be able to fix a bug or add a new feature, then it demotivates you from wanting to continue contributing to that. And on some level, that goes back to all the findings that we also work on that project.
I think my advice would be find the thing that gets your community excited. So why would that project that you're trying to put out there, why would the users want to use it? What empowers them, and how do you get them to be passionate about your technology or your code and your environment? So back to that community building. How, and actually it ties in what both of you just said, it comes down to the community. So how to get them excited, other people excited to come in and use your tech. But how do you make them feel good about it? Have that motivation. So I keep it simple like that in the past.
Right. Do you have any questions from the audience? Wow. All right, I'm gonna start with the Lieggi spot and then works.
Yeah.
Feel like I got a spotlight.
You can move on wherever you want.
Mobility. So at lunch, I don't know, did I just turn it off or not? Okay. At lunch, our table was talking about finding someplace to live in the Bay Area. And somebody mentioned that they have a spare room and they put it up on this website for UCSC, said, hey, if I have a room, do you need a room? Somebody came along, said, yes, I need a room for just a couple of months because I'm a researcher. And, you know, so there's this resource where I have a need, I have a thing you need, and people can meet up. And I guess this is a question for the person standing right behind my left shoulder. Oh my gosh. I'm sorry, I thought it was still there. Is this something that has been tried by either UCSC for the OSPO or any other academic OSPO to have like this hub where people can, like students can look and go, okay, you need documentation? Well, I'm a writer. You need this, I'm that. Does that have exist yet?
Not yet. But I'll let Emily talk. But I was gonna say, I think that's a really good idea. Have some thoughts on it.
Yeah, I'm not gonna lie. I think it's a really fabulous idea. I think what Steph may be wanting to talk about was that we are working right now with the other UCs that we're in like collaborating with to try and like discover more open source projects that are on campuses that we don't even like know about, that the OSPO folks don't know about. Because like we know there's a ton of open source happening. Like we know that people are both like contributing to external projects and we want to know those people. Like upstream stuff, we want to know that. And we know that there's people who have their own projects, all right. So yeah, I think we're doing work right now to try and find those projects, and then we're going to do follow-up work to connect with people in those communities. We have a community manager who will be coming on to do some of that work. And then I love this idea, so maybe that's something that we could think about, like how we specifically implement that. So yeah, thank you for that question / comment. Yeah.
Any other comments on that?
That actually does exist.
What,
The community has it.
for open source?
Not for open source.
Okay, what did you tell me? And then
No, as we mentioned, actually does, it's not open source, but actually does exist. And then it's actually one of the problems that was kind of brought up during the symposium of, you know, what happens when that person leaves, that single point of contact that's been maintained in that database. And where, you know, this list exists for faculty and grad students and the community housing list. I believe that person maintaining it is leaving or has decided not to do it again. Well, and sent out a call about a month ago saying who wants to take this over. So, and it's not for undergraduate students because that'd be a little bit more of a headache, but I know it is in place for faculty and postdocs and grad students. So, but it's one of those things where just because you can make it open source doesn't necessarily has to be open source. So,
I think what Lieggi was talking about was like a marketplace for projects.
Right. And that's another one to point out, of course, is that we
Yeah.
do like just like GSOC, we do the just like GSOC, we just copy GSOC. Like GSOC, because we copied exactly what GSOC Google Summer of Code does. The open source research experience program has that ability as well. It's not as widespread, it's not as large of a marketplace as what we want it to be, but we're trying to expand that throughout the UC network. So the idea would be that for that marketplace, it's like you have projects like Jose's been a mentor for how long? Forever. I mean, since we've been doing it, you've been a mentor. Emily's been a mentor. And what they do is they put basically put the projects out, or so, you know, ideas for projects that students could do. Now we do it in the GSOC through the GSOC portal, but there's no reason why we can't do that, and we can actually do it also for local students. We just haven't gotten funding because GSOC will fund our students to work with us, and they only fund up to students. So that's where we're headed. That's why when I said not yet, I said, well, we need some. There's a little bit of like some way to help that. Well, that we could do it for credit over, you know, but we can do something where they're getting, you know, different experience that it doesn't, you know, I like to always compensate the students. I know that's strange and open source to maintainers, but who are for their work all the time. But for students, I feel like it's important. And so, and also from the accessibility and diversity perspectives and inclusive, I think it's important to make sure that people are compensated for their work. But that is an idea. Long story short. Yeah, there.
So most of you on the panel has really interesting open source experiences and stories. If I could send you back in time to the beginning of your open source journeys and you could do something differently, what would you do differently?
Okay, who's first? Oh, I'm scared. All right, come on. You want to try? Okay.
I think for me, if I ask students this question, or I can like give advice to like the future cohort, and they say the same thing that I'm about to say. which is that I was very, very afraid to go and talk to communities. Like I was afraid to like drop in the Slack channel and introduce myself and ask for help. My students experience that as well. And like we all agree that people have just been really welcoming and supportive, like as soon as we've done that, because we've been thoughtful about what community to interview that in. So yeah, I don't know, just like send the Slack message, reach out, like you'll find your people.
I'm still thinking on it.
I don't have a great answer, but I probably would have written more documentation.
Good answer, good answer.
Probably I'll say there's so much time answer. I have been thinking that there 60 or 70 different projects I can think of off the top of my head. I think the biggest problem is there's so many issues in both projects with Chicago. And it's hard, at least maybe just for me to always constantly switch between different codings. So that's a project to work with the more-term code base. Organize my code base for 95 code base, which is Haskell or basic, or it's just, it's hard. So it just happened lots of projects we're focusing on a view and making those view really good, it's fine. At the same time, the project is to exist and you want to have your own opinion for it, sure, put it out there in the world, but then people, you have to be prepared for people to know that you're gonna sucks.
So I have one. So usually development and community. In my case, I've been more focused. I am your community. I'm the main user. You have to be me and convince me that we want this feature. So maybe I need a little more community on that thing, or because I want to be the main user of whatever thing I'm using. I'm building.
We're just adjusting the gear. Yeah, we got time for questions.
I mean, this is probably, I was just curious about, this is mainly for OSPO folks, and this, I'm really interested in this idea of developing like a community of students to kind of help for like several reasons, for, you know, to help contribute to the projects, for their like, I mean, essentially it's research experience, right? Because these are academic projects, and undergraduates are so hungry for that, and we never have a good answer, you know? Because a lot of times it takes so much time to get them up to be contributing to like the new research that we're doing. But like when it comes to these like established projects, there's lots of things, and they get experience with academic privilege. I'm wondering if this could be framed enough like an educational experience that things like NSF educational grants could apply to. And do we know, like, have you looked into that? Do you know if that's in the scope of these kinds of programs?
Yeah, I think it is where, I think there was one recently that was a workforce development one that I was like, it might work. We do have to do a little bit more research on that, but even just REUs, we have that. It's very similar. I mean, we structured part of the OSRE kind of like the RE set as well. So I mean, we just haven't been able to kind of think the two. Like we haven't done our right. Exactly. Yeah. So to look for new grants and stuff. So RE for everyone who doesn't know it's research experience for undergraduates. Yeah, and so thank you. That's Karen for research development will tell us. So I think any thoughts on that? Okay, we'll ask Karen about this next week. So Karen, by the way, is the one who helps us write healthy grants that everybody, well, all of the Baskin engineering people probably have a lot to thank Karen for on that. So, any other? Right. Did you have a second? And then I'll get the last one, and then I think we're done.
I have a couple of comments on that. Number one is, the REU program. We looked into this. I almost applied for an REU last year. REUs just don't provide. It's like a small group of students. It's not that much money for the person who's running it. It's a lot of infrastructure. I think the program's amazing. But to be blunt, I want to think bigger than that. So cool. Maybe we can talk. I previously taught for 3 years at a school, a mission-driven school in Kentucky. Found that job through open source, by the way, super cool. But there was somebody there who was running we had a student software development lab that was like, there was a faculty member involved, but like students were mentoring students on software projects. So I fully believe in this model. And I think like the main limiter to us doing this at UCSC right now is just that our OSPO is 3 people and we all get excited about a lot of stuff. Four, yes, thank you, Yelena. Oh, she's indispensable. Yeah. So yeah, all that's just to say, like, I love this idea. Like, we've talked about this. We would love to make this happen. And there's people on campus like David Lee who are doing work where students are supporting students. So I think there's a path. We just have to find it. Awesome.
I've got 2 questions. Oh, sorry. Yeah, we'll get the last 2. I might do you both together.
Sure. If I could just add, I mean, I did undergraduate research and I thought it was great, but as a PhD student, I felt that it's kind of, I don't know, the way it works a lot of times, you get undergraduates who are like, I'm super excited to do undergraduate research. They show up, I'm like, this is great, we have this project, and then they don't show up. Or they're already a senior and they have 6 months to work on the project and they get up to speed and they're gone. And so I find it's really hard to get a student at a stage where they can sort of get up to speed, they have the time and they're committed. And the ones who do that are great and they do great work and they're really valuable and they get a lot out of it. I think we get a lot out of it. But I don't know if there's maybe a more formal like structure where maybe they are more committed and they joined maybe before their senior year and they're about to leave so they can get more time working on projects. Yeah, I just think that's a yes,
I'm gonna, and then actually, sorry, I can go there. I got the last 2. Can I just copy you both?
Thank you. So for the students that are getting started in open source, beyond like technical know-how, what are some of the areas that they need the most help with? I think Emily, you kind of mentioned that being comfortable, like asking questions, is it things like being comfortable working in the open? Working asynchronously, like what are the areas they need the most help in?
So we have been talking a lot about motivation, funding, community, and how to involve students in it. So that makes me wonder, how do we make it fun? Because I was at one of India at a great time, but I didn't see how. I like 2 projects that the prof Jose is doing and Scenic is doing. But it would have been much nicer at one of India if there was a fun aspect of it was shown, or like how it could have made it better for them, like fun specifically. So how do we make it better for them to be? Yeah, because usually people see something of value out of it, or fun out of it. So how do we make that thing?
Did you say fun?
Yeah.
Like how do you make it fun?
Yeah, that's fun.
Like, let's make questions for together. Do we want to just pass it? Did everybody have a? We'll go. Corbin's all the way over here. It's like there's open source and then there's.
Because I'm officially this one's. No, so my experience with this one, so a little bit more background on me. My background is biomedical engineering and material science. I built and ran Clarion University's technology incubator. I ran that for over 6 years. I had over 50 interns ranging from business, computer, CIS, biology, chemistry, physics, and so on and so forth. We developed internal intellectual property and did coordinated sponsor research projects as well. And I would happily say I had more students showing up on my campus to be able to work with me because I was able to find projects that empowered them. So and what I mean by that is it's not just saying, hey, you're going to be doing something like episodes. You find something that you're passionate about to develop, to get involved in that open source community. And then, of course, it doesn't hurt to be able to pay them hourly. But it's one of those things where by giving them something to be passionate about, then you offer them the mentorship to get to that point where it's just enough where they feel empowered every time they hit a milestone that they're excelling. So it's about them like working hard for success over and over and over again until they actually obtain that goal. So that is my experience with it. It's not so it's that cross section between your intent and your goal of what that educational opportunity is and finding a way to merge it with the passion of that specific student. And I understand there's a limiting factor with the number of students that you can handle at a time by doing this. But that's where I've seen amazing results. And all those students have been able to go on to different things.
So, I want to say, it first of all, I kept my mind start for fun and functional programming. But, one way to make it more clear for students quickly is that even though there's going to be lots of students, at least in my experience, who are always looking for blocking to do. Now that we talk that we have on some level, there's more about trying to find the right fit for those students. Maybe nothing that you have is going to work with the students, though they want to work in conflict or something like that. But not having anything for them is also okay and just dangerous. Even though you might be to the point that it's not. I think it's neat to say that it's not really our responsibility to do this stuff. Every single student that comes looking for projects. They have plenty of options as campus. Doesn't have to be like what is the environmental, physics, or even be like chemistry, or aerospace, something like that. I think it's really just about finding the right story that works for them because at the end of the day, most students are going to need to present their project in some way or form. They're going to need to have a story that they can bring or personalize to them, and you need to kind of motivate the project from their perspective. And if that doesn't happen, I don't think it's be funny.
So to answer the first question about what the best qualities I think for working in open source, in my experience, it hasn't even been willingness to ask questions because I think any student will ask me questions. The students that really do well are the ones who ask questions, but then they don't just ask questions, they jump into the code, they try things, it breaks, and they can iterate on their own. Because there's plenty of students who will just ask me a question and they'll be blocked until I get back to them. And that's great. And I think, they learn a lot, but it's not really as productive as it could be. It's not really useful for me because I'm basically doing the project hand in hand with them, which is, of course, at the start, to get up to speed, that's normal. But at a certain point, you have to be willing to just try stuff and break it and then come to me with what you tried and we can go from there. When it comes to fun projects, I think that, I don't feel like I want an undergraduate to help me on my project if it's just going to be like grunt work. I only want them to do a project that's interesting and that I think is actually a research project. And of course, undergraduates in general, developing Scenic, for example, developing the tool to actually do something interesting. That's a new question, not just update documentation, something like that. So that's what I think makes it interesting. Fortunately, I think a lot of them aren't really ready for that step. And or it takes time to get them up to speed for that. And so I think that the fun is sort of, are you ready for that? Do you need time to sort of get your fundamentals so you can actually contribute in a fun way? Because the alternative is to do something that's not really fun on the project and do grunt work. So I think it's sort of a question of there are fun projects, not everybody's ready for them. And I think the research itself is sort of the fun project. Yeah.
So I agree with the first part that the student tends to perform better than who are more hard like. What do I do for fun project? I'm not working on a project unless I enjoy it. But the problem is that the student might not enjoy that. But many times I need them to try things that I don't have time, that I think they're kind of cool. And if it works, then we'll see how do we integrate on the thing. But they're sort of like pathfinding. Exploring ideas, and that tends to keep them interested because it's cool, my work might not work. They try to push it because put them on the main maintenance for infrastructure. They don't tend to have a long-term commitment, so then it's not such a great quality. And then different things that.
So to the first question, which is about things I see be hard for students. I do think working in the open is sometimes new for students. It takes adjustment. Particularly, I think writing, just communication in the open is new for a lot of my students. So honestly, we write a lot of stuff together. We write a lot of Slack messages together and issues together. And we don't do it forever, but like maybe the first one, we might do that as a group. And then by the end of the time, I work with students, like they're off writing all their stuff. So that's one thing. Maybe the biggest thing that I see hard from students is like trying to figure out like what is the next step, because there's no like instructions in open source that are like, first you do this and then you do this. Like it's all very context dependent and community dependent. And then you have to align that with like, what skills do I have? What skills do I need? So I think that feeling of like feeling lost or like, oh, now I have this huge code base and I don't understand any of it. Like helping to guide and support students through that is really, really important. So I think that I like to think of it, I talk to students about it, like you're going to learn to be a really good detective, right? Like figuring out like what to Google, when to talk to a human and what human you need to talk to. So that stuff I think is some of the biggest challenge I see. And then the third challenge I see with students is kind of logistical, but also, you know, something we can improve, which is just how do you maintain a practice as a contributor and stay involved after like the program you're in, once your school year starts, etc. In terms of fun, I'm not sure if the question was about general fun or like specific projects, but I am very big on fun. And I would say like, I do agree with this thing about fit. I think fit is really important. My idea of fun is not going to work for every student, but like, I'm a big fan of like, someone told me about the idea of like a push party when you like get students together and they all do like their first like push to a project, even if it's your own project. I have students modify poetry. That's another idea I got from someone else to do their first PR. I'm hosting a Hacktoberfest event next week for students that I hope will be really fun. So I think there's just a lot about like celebrating victories together, looking about things with a certain mindset. So like, I guess to use some of the younger generation lingo, like I think vibe is very important. And if we can like help, you know, connect people with projects that are like the right fit for how you like to work or communicate, et cetera, that can help support more.
All right, we're officially closed. Okay, well, thank you very much, everybody. All right, I am seeing catering get up. I see Elena working on setting up the drinks. So I'm thinking at least the drinks probably maybe that's another video, but that seems right. Thank you. We are officially over. The symposium is over and the Oktoberfest is beginning. Again, thanks to the panelists, thanks to all the speakers, thanks to people who came in from out of town. They go to eat before they enjoy their beer, but hopefully enjoy this one. And then, enjoy. We will. I'll keep everybody informed about all the fun things that we are up to. Always fun. Again, Oktoberfest is the 10th. Ideathon soon after that, and a bunch of other activities. Slugfest, our UC-wide open event coming up in the spring as well. And and find us here on campus or at our website if you have any questions about it. Okay, great, thanks. And thank you again.